The sun, a giant ball of burning gas. It is the heart of our solar system. The sun's gravity holds all the planets in their orbits. It provides the light and warmth that makes life on Earth possible. But the sun is not always calm and peaceful. It is a dynamic star, constantly changing. Deep within its core, nuclear fusion reactions release immense energy. This energy travels outwards, creating powerful magnetic fields. These fields can twist and tangle, storing even more energy like a coiled spring. Solar flares are dramatic events, but they are not the only way the sun unleashes its fury. Sometimes the sun ejects vast clouds of charged particles into space. These are called coronal mass ejections, or CMEs. CMEs are much larger than solar flares. They carry billions of tons of solar material traveling at millions of miles per hour. Imagine a billion hydrogen bombs exploding at once. That is the scale of energy released in a CME. Our technological society is increasingly vulnerable to space weather. Solar flares and CMEs can disrupt radio communications and GPS navigation. They can damage satellites, causing failures in communication and data transmission. Imagine a world without internet or cell phones. Imagine power outages lasting for days or even weeks. These are some of the potential consequences of a major solar storm. Astronauts in space are also at risk from solar radiation. During a solar storm, astronauts outside the protection of Earth's atmosphere could be exposed to dangerous levels of radiation. This radiation can damage cells and increase the risk of cancer. It is a serious concern for future missions to the Moon and Mars. Scientists constantly monitor the sun, studying its behavior and trying to predict these powerful events. They use telescopes on Earth and in space to observe the sun's magnetic fields. They track sunspots, which are cooler, darker regions on the sun's surface that are associated with intense magnetic activity. By studying these features, scientists can identify areas of the sun that are likely to produce flares or CMEs. They can then issue warnings to satellite operators, power companies, and other organizations. These warnings give us time to prepare for potential disruptions. We can adjust satellite orbits, protect power grids, and postpone spacewalks to minimize the impact of solar storms. The sun is a complex and dynamic system. Its magnetic fields are constantly shifting and changing, creating a beautiful and intricate dance of energy and matter. This dance, while mesmerizing, can also be dangerous. Solar flares and CMEs are reminders of the sun's power. They are a testament to the immense forces at play in our universe. These events challenge our understanding of physics and push the boundaries of our scientific knowledge, but they also inspire awe and wonder. They remind us of our place in the cosmos, orbiting a star that is both life-giving and potentially destructive. As we become increasingly reliant on technology, understanding and predicting space weather becomes crucial. We must continue to invest in solar research, developing better tools and techniques to monitor the sun's activity. We need to design more resilient satellites and power grids, capable of withstanding the impact of solar storms. We must prepare for the possibility of a major solar event, one that could disrupt our way of life for weeks or even months. The sun is a constant presence in our lives. Its energy sustains us, but its fury can also threaten us. By studying the sun and its behavior, we can learn to live with its power and protect our technological world from its wrath.